Welcome to the first screencast of the year. So this is Unit 1, Lesson 1, and it's going to be on proper measuring technique in the lab, as well as what standard units that we're going to be expected to use every time. It's going to be kind of quick because I'm expecting most of it to be review for you. So, why measurements? Well, you can't really do much of anything without measurements. You can't prove if something is changing or not unless you have accurate measurements to compare them against. So you're going to need measurements to prove or disprove your hypothesis, which you should remember. Hypothesis is your guess, your educated guess of what you think the outcome of the experiment is going to be. Okay? So it's important to have excellent measuring techniques for valid results. Many of your labs throughout the year are going to be graded on your ability to measure. The accuracy of your results are going to be based on how well you measure. So it's important that at the beginning of the year you get really good at measuring and keep up with those skills throughout. Okay, so in science we use the metric system. It's the metric system, or sometimes it's called the SI system, International System of Units, but they are the same thing. So remember, the metric system is grams, kilograms, meters. So why do we use metric system in science? Well, to be honest, the entire world uses the metric system. The only place that doesn't use the metric system is America. America still uses its own American units. Now, the American units are really poor, they're really messed up. Do you know where we got our units from? The foot was the size of the King of England's foot. A yard was the king's arm span. So all these measurements were based on like the dimensions of one person, or a horsepower was how much weight his personal horse could pull. So those units really didn't have a good thing to be based on. The other thing that's really messed up about the American units is that there's so many of them. You can't convert between them easily. So if you were cooking, you might need to use cups, pints, quarts, ounces, gallons. There's all these different units, and none of them work with each other nicely. Some people have a big table of conversions on their fridge just to help them cook with American units. Metric, on the other hand, they all mean the same thing. So if you have a kilogram, right, it means 1,000. Or if you have a kilometer, it means 1,000. So all those prefixes mean the same thing, making conversions between units very, very, very easy. If you don't remember how to do those, don't worry, because I'm going to have a separate screencast on that. Okay, now, what this is a table right from your notes. This is what unit you'd be using if you were measuring these different things. So when you're measuring a length, you're usually going to use either a ruler or a meter stick. Your unit would be meters and your symbol would be lowercase m. I want to point out that whether these are uppercase or lowercase is important because you're going to have more than one symbol as we go throughout the year. Okay, when you measure mass, it's going to be in grams, and again, lowercase g. When you measure a liquid volume, which remember is how much space something takes up, it's going to be in liters or capital L. Now, every time we measure a temperature in lab, it's going to be Celsius. In fact, our thermometers only have Celsius on them. So that symbol is degrees C. Kelvin. Kelvin is another unit of temperature that we're going to use in calculations, but we're not going to directly measure. Okay? So just note that it doesn't have a degree. Kelvin is all by itself. It's just a capital K. Okay, so this is a very quick review of the prefixes of the metric system. So like I said, kilo always means 1,000 base units. So if our base unit is grams, then this would say 1 kilogram equals 1,000 grams. 1 kilometer equals 1,000 meters. So base units always goes back to the units that we wrote on the previous table. Okay, so these are some prefixes that I would definitely memorize if you don't know them already. But again, if you don't remember how to convert, don't worry. I'm going to do a separate screencast on that you'll have the option to watch. Okay, so I want to get right into what equipment we're going to be using in the lab and how you're going to use it to measure the various quantities. Okay, so measuring a liquid volume. This says here, always use a graduated cylinder, it's the most accurate. So you have a lot of equipment in the lab that has these markings on it that would let you measure a liquid volume. For example, the beakers and the Erlenmeyer flasks are going to have these markings on them. But the cylinder, which is what this guy is the most accurate. So anytime you need liquid volume measured, you want to use the graduated cylinder. Okay, so let's get into how to actually measure with it. Okay, so it says liquid inside the cylinder creates a curved surface. So because liquids have surface tension, they're going to stick to the walls a little bit and they're going to create this curve. Okay, it says the curved surface is called the meniscus. So you definitely need to know that term. It's going to keep coming back. So what these are is the steps of how to use it. It says leave the cylinder on the table. All that means is you can't hold it, you can't pick it up to your face, because the liquid won't stay level. It'll be way too hard to hold it still enough, so you're just going to want to leave it on the table. View the meniscus from eye level. So this usually means you're going to have to crouch down so that your eye is at the same level as the meniscus. It says measure from the lowest point. So your lowest point is going to be somewhere down here. That's the point that you're going to line up with the markings on the cylinder and make the reading. Okay, so we're going to look at a couple pictures and practice figuring out what number we would actually write down. So one of the rules I didn't tell you yet, every time you take a measurement in the lab, you need to record one extra number that you have estimated, that you can't perfectly see. Okay? So let's try the first one. So this is just zoomed in. This person's eye is at the level of the meniscus, so they're doing that correctly. If you look, there's 10 lines between the 60 and 70, so each of these lines mean 1 milliliter, because notice the graduated cylinder is in milliliters. So if I was to count this, 1, 2, 3, 4, 5, 6, 7, there are 67 milliliters. Well, this lines up with 67. So you would write 67, but you need one estimated digit. Because this looks like it's right on 67, I would be comfortable with just putting 67.0 milliliters. The O can be our estimated digit. Now, remember, your data needs to be recorded in standard units. So what we need to do with this is to convert it to liters. So that would be 0.067 liters. Again, don't worry if you forget how to do that. Okay, so let's look at this one. Again, every line is 1 milliliter because there's 10 lines in between here. So this is 35, so I can see 36. But I have to decide how far I think it is in between these two lines. I think it's a little more than halfway between 36 and 37. So I'm going to say 36.7. You might say 0.6. You might say 0.8. It doesn't matter. That last value is estimated, but you need to have it to be doing good science. Again, you want this value to be in liters, so that's going to be 0.0367 liters. Okay? And that's what you would record in your data table. Cool. Let's look at another tool. Okay? So the next tool is the digital balance. This is actually the exact digital balance that we have in lab that you're going to be using throughout the year. So the rules here, always zero the scale before use. So this is the 0 button. You're always going to want your scale to read 0 before you use it, otherwise you're going to get an inaccurate mass measurement. Okay, the next rule, never place objects directly on scale, use the weigh boats. This is a weigh boat right here. So basically it's just a piece of plastic that allows you to have a barrier between whatever you're measuring and the balance, because some chemicals are going to damage the balance, so you're going to want that barrier in between there. Okay, so how you use these weigh boats. You put the weigh boat on the balance and it'll give you a reading, something like 1 gram or something like that. Then you're going to want to hit 0 again so it will ignore that weigh boat. So then, whatever object you put in here, I don't know, whatever object you put in here, it'll only give you the mass of that object as opposed to including the weigh boat. Okay, so that's what you're going to want to do to be able to do these quickly and not have to subtract off the weigh boat later. Okay, now, when you are recording your measurements, notice that the balance is already in grams. All of ours are already going to be in grams, so you're not going to have to do any conversions, so that's nice. You have to record all of the values it gave you. So if you wrote this down, it'd be 279.3. What this 0.3 is the estimated digit. The digital balance is giving you its estimated digit. It doesn't even know how much it is. Sometimes you'll see this jumping. You'll see 279.2, 279.5, and it'll keep bouncing back and forth. You don't have to worry about that. If it keeps jumping, then you want to record something that's about in the middle, because again, its last digit is also estimated. Cool, easy enough. Okay, now, using a thermometer. This is the exact thermometer that you're going to be using in class. Well, not quite, because this one has Fahrenheit. But the one you use in class only has Celsius, so you kind of can't mess it up. You can only read the correct scale. Okay, rules for the thermometer. Never stir with the thermometer. We're going to be using a lot of solutions that you have to stir throughout the lab, but you're going to want to use a stirring rod. If you stir with the thermometer, it's really easy to break it. Now, thankfully, our thermometers don't have mercury in them, so you're not exposed to poison if they're broken. But we would have broken glass that we would need to deal with, so please let me know, because I'll help you clean it up, because you don't want to get any of it stuck in your fingers or anything like that. The other thing, always clean them off after use. So some things we work with will dry and then be really hard to clean off the thermometer later, so make sure you clean it at the end of the lab. Okay, let's practice actually reading one. Now, like all measurements, you have to include the estimated final digit. So, this thermometer is just like our ones in lab. Each line is 1 degree Celsius. So, I can see 26. Whoops. I can see 26, and then I would have to estimate in between here. It looks to me like it's perfectly in the middle, so my estimated digit would be 5, 26.5 degrees Celsius, and that's already the unit we need, so we don't have to convert anything. Cool, let's try this one. Well, easy enough. It looks like it's right on 30. Even though it's right on 30, you need the estimated digit, so this wouldn't include an estimated digit. My estimated would be 0.0, because it looks to me like it's right on it. Okay? So that's how you would use the thermometer. Pretty easy. Okay, so this is right from your notes. These are some standard temperatures that it's going to be way easier on you if you memorize them. So the freezing point of water, maybe you already know it, 0 Celsius. It's a little messy, 0 Celsius. Boiling point, 100 degrees Celsius. The body temperature is about, so this symbol means about, 37 degrees Celsius. So you'll need that every now and then throughout problems where it'll just expect you to know them, but they're not too bad. The other thing you need to know about temperature is when you do a measurement in Celsius and you want Kelvin, all you have to do is add 273. So it's actually super easy. So for example, the boiling point of water in Kelvin is going to be 100 degrees plus 273, which we know is going to be 373 Kelvin. So, easy enough. There's nothing difficult about those. Okay, I think, yeah. Okay, so that's all we're looking at today. The next screencast will be on density and unit conversions in case you need to review those. Okay, thanks.